Here are two of the latest 17.5 turn brushless motors for touring car racing. Just hit the market. Supposed to be better and more improved than anything else. You've got the Fantom. This is a 17.5 Type M. It also says Special Edition, 12.5mm high torque rotor. And then you've got the Motiv M code. It's handwritten on here, 17.5. Don't know what that little mark is there. Comes in this plastic container. Now there's lots of information that they're quoting for these two motors. The specs are here. Now the Fantom has got some very interesting claims. Using premium Kawasaki steel for the stator, which is an excellent material to use, but will give very high efficiency, good magnetic transfer, and will give very good performance. For the stator, down here, 12.5mm high torque rotor, precision balance, this is all normal stuff. High grade neodymium magnets, well, the top motors will be using that now. It doesn't fade with heat. Premium grade steel, you've already mentioned that. The best copper high temperature wire, well, that's essential now. Stop them burning out or melting when they get overloaded. Low resistance, high power, gold plated solder lugs and collector ring, which are the connecting parts inside. That's all real good. You want the best you can get. Machine billet, aluminium, precision bearing alignment, that's all good stuff. Venting for maximum cooling, yeah, more modern motors have all that. Sensorless operation, yeah. Inspection window, for that be for the size of the stator, so it meets the rules for minimum length. Infinite adjustable timing. On most motors you need to be able to adjust up to 60 degrees or more. So that's normal. High precision bearings. All motors have that. And meeting legal requirements for racing. That's the Fantom version. On the M code, they speak about similar sorts of thing. There's a short stack. Well, it can't go below a certain length, otherwise it won't be allowed. So we have to measure that. Designed for low resistance. Well, you'd only get low resistance if you had a short stack and former, and the wire wrapped round it was also shorter. So they'd be interested to measure the resistance of the wire. Specially selected stator material for low power loss. Well, if it's the same as the Kawasaki grain oriented steel, that would be good. So they don't actually say. High quality pure copper wire, yeah, same. Emphasis on hand winding for consistencies. Well, all stators are hand wound. There's no machine that can do it properly, and the girls, whatever, have to be very careful with the thick gauge wire that they can get it all in. Otherwise, it won't go through, or it develops a lump of wire sticking out. So that's normal. Solder tabs, gold plated, pure copper tabs, low resistance again, yeah. Internal drop connection, designed to ensure low resistance, consistent internal solder joints. But the internal solder joints are very important. A lot of motors have very poor solder joints. So just stick the wire through a hole and then surround it by solder, which isn't the best. The wire should be really pushed down and connecting directly to the metal plate inside. So I need to see what they mean by that. Rotor, sintered rotor, that's normal. Same magnet, yeah. Can assembly, vents, yeah. Machined aluminium front end, yeah. Adjustable timing, dual precision ball bearings, all the same stuff. Every motor is tested in-house during the assembly and packaging with specs test sheets. But that's quite a lot of work if they actually do that. So it'd be interesting to see how good the motors are, whether the test sheets give you any useful information. meets the specifications. It's a lightweight, so we can measure the weight as well. So both motors are making good claims about their performance, so they go head to head. I'll test them as they come on this tester, then I'll optimize the performance to identical current, say 6 amps, and measure the kV, etc. And if I've got time, I can also put them on a dyno with a heavy flywheel and compare. Here are two motors out of the boxes, similar in appearance, like almost really the dark sort of grey or bluish colour, greenish colour. This one got the stack a long way forward. You can see the stack here. It's got some signature on it as well. It does look short. I haven't measured it yet compared to the stack on this one, which is from there to there. Vents, big vents on this one. Slightly smaller. That one bent over solder tabs. They're very thick on this one. The end bells. This one's got the marks around the edge here. This one's got the marks down here for timing. Also, you've got an open bearing showing, and this one's got a little insert on there with 3 adjusting screws on each one. This one comes apart by undoing the screws on this side and then pulling the front off. This is one which is more conventional, with the screws going through from this side, and then this front comes off and the back, obviously. Anyway, let's weigh them. We've got some scales here. Let's do the M code. Let's just see so you can see it. M code 158 grams, and then the Type M Fantom 166. So 158, 166. Now they did say that this is the short stack, and we know that the short stack of 1S are lighter. And in fact, if they did a short stack one of these, it would be lighter. Anyway, I'll measure the stack lengths if I can and see how the stack lengths come up. Stator length of the M code motor, about 19.55. My stator length of the M code 17.5 is just about 19.49, and measured in the window. M code timing as applied out of the box, 45 degrees average, spread 42, 45, 47. On their spec sheet that comes with the motor, it says 46 degrees and a spread of only 3 degrees. So their tester is slightly different to mine, but it's at least 45 degrees. A lot of motors are only supplied with 30 degrees, but Embello as supplied as standard, it's showing about 43 degrees on the marking. The M code as supplied as standard, the it's 3.5 amps, kV 2466, revs just over 18,000. The Fantom 17.5 is supplied as standard, it's 28 degrees. And very tight on the timing, 27, 28, 28. As supplied, the motor has, I just moved that out of the way, only 1.4 amps, kV 2371, rev 17549. Timing on the Embello supplies is just about on the 30 degree mark, and it came out at I think 28 on the tester, so it's quite accurate. Resistance of the individual windings with this very accurate ohm meter is 0.045 ohms on one coil. Let's get on there. 0.045 on the second coil. 0.0456 on the other coil, so they're pretty well wound, and that's a typical reading for 17.5. That was the Fantom type M. Winding resistance on the M code, tiny bit lower, 0.044 stroke 45. It's quite difficult to hold these probes on, but I'll try and get another one. You've got two contacts you have to make on here. 0.04455, so it looks like a fractionally lower winding resistance on this one. Let's try the last one. 0.04445. Measuring the inductance, the three poles vary slightly, but the highest inductance is nearly 57 microhenries on the Fantom. The inductance on the M code, I measured a 4848 and 52 microhenries is the highest, which is a fractionally lower than on the Fantom. The M code, I've adjusted the M bell to 6 amps draw, so, and it's drawing, giving you 2765 kV, 19, just over nearly 20,000 RPM. Timing at 6 amps draw, average 50, and the spread is 47, 51, 51. On the M bell, it's on the scale, it's showing about 48 on their mark. The Fantom set to 6 amps, kV is 3108, RPM 20,384. Timing is 50 degrees with a spread of 48, 50, 52. Timing's about 54 degrees on the M bell. Here's the rotor out of the Motiv M code. It says Motiv 1315, it's laser engraved, and also on this where the pinion goes it says S-high. So the diameter 1245. It's a bit difficult with the magnetics. So let's measure the Gauss. Pretty strong magnet, 1528 on one pole, 1530 on the other pole, very nicely matched. 1528, 1530, very nicely matched magnets. The rotor from the Fantom, there's quite a lot of laser engraving on it. Fantom, the code FAN 19591, raw spec. Nothing engraved on the pinion part. Again, it's difficult to measure the size being magnetic, but I think it's just under 12.45, say 12.43. Let's measure the strength. Say 1411, 1421. So it's a bit weaker than the M spec, but quite well matched. It's interesting to see that the Motiv rotor it's got these little holes in the end. There's no signs of how it was balanced at all. Fantom rotor is solid shaft. It's got this alloy black ring glued to the end of the magnet, and then some hard epoxy that's been set in there for balancing. Two stators, the Motiv and the Fantom. Not a lot of difference the way that the wires are terminated and soldered into position. Very similar. Let's weigh them. This is the Fantom, 110 grams, and the Motiv, 107 grams. So very slightly lighter for the Motiv. Sensor boards, quite a different manufacturer obviously, but the sensors are still on top. The one from the Fantom is fairly normal looking. Seen this on a lot of motors, this one. The one on the Motiv is, I've seen it's on some other motors where it's sort of an insert that pushes into the stator, and this one is held on to the back plate. The sensors on this one are slightly angled as well on the Motiv. The M-Code 17.5, after I reshimmed the rotor to the distance to the sensor board as close as it could be without any rubbing, it got a slight increase in performance of kV 2790 and RPM 20,095 at the same 6 amps. As a comparison, here's Revtech 24K 17.5 set to 6 amps, kV 3079, RPM 21865. Motor timing is average 50 degrees. The spread is quite large, from 47.48 to 55. Revtech M-Bell is showing just under 60 degrees on the marking. Revtech weight 17.5, 24K, 163 grams, so about similar to the others. Okay, I've got all the results from the analysis of these two motors, the Motiv and the Fantom 17.5. I also had a look at the 24K Revtech 17.5 just as a comparison at the end. I've got all the results here which I've recorded, and got the Fantom, Motiv and 24K. Tested them as they came. Interestingly, the Motiv comes with quite a high 45 degrees advanced time in the supply, whereas the Fantom is nearer the 30 degrees which you normally get on most motors, and those are the figures that you got as supplied. But we're more interested about when they're set up to an optimum point. I found personally that setting them to 6 amps gives a very good performance on the track. It's always proved itself to be very good doing it this way, no matter what anyone else have ideas about how to do it. Gives a very accurate indication of how a motor's going to go. So I set them to 6 amps, both, and check the timing on the end. They both had 50 degrees. They both came out the same. They're quite close on the 3 phases on the timing. Not perfect, but pretty close. But then it's the kV and the RPM we're interested in. And you can see that the Fantom had 3108 kV and the M-Code only a 2765. The revs achieved 22,384 versus 19913. I did reshim the M code to see if I could improve it, shimming the rotor close to the sense board. Got a very small increase in performance on revs and kV. I did all the measurements on the resistance. The Motiv has got a fractionally lower resistance on the winding. It's very small, but it is. I did measure it. Means that the winding is good quality and well, nice and tight. The stators. I measured the length of the laminations. It's quite difficult to do. There is small variation depending where you put the tool. Calipers. The Motiv over 19.55. The Fantom seemed to be slightly smaller, about 19.5. I also measured the stator weights. Fantom 110 grams, the Motiv fractionally lighter, 107 grams. And the whole weight of the motor, the Fantom was 165, the Motiv 158. 3 grams of that from the stator, and obviously a few grams from the general construction. As a comparison, the Revtech weighs 163 grams. I didn't take the Revtech apart to weigh a stator. I have checked the Revtechs before, and the resistances are 0.045, the same. I checked the inductances. It's lower on the Motiv than the Fantom, which means there's slightly less magnetic quality or amount in the stator, which probably shows up because it's lighter as well. Measuring the rotor Gauss, the Motiv is stronger, around about 1530 on my tester, and very accurate from the plus pole and minus pole. The Fantom around about 1400. I've always found about 1400 for a touring car was the best. Normal touring car, Blinky racing. So I would have preferred that one myself. They're engraved with the numbers. So what can you make from all this? Well, look at the Revtech as well. The Revtech kV was 3079, and the Motiv was way down at 2765. Now you can obviously push the kV and RPM up, but the current goes up as well, which means that you'll be drawing, it'll be less efficient. It's going to get hotter, and you're going to really work the motor hard. But you can do that on some tracks. But as I said, it's an exact comparison. The Fantom just shades it on the Revtech a bit more, and a little more revs as well. So, conclusion, from these results, I would say the Fantom would give you the most performance on the track, followed by the Revtech and the Motiv. You might have other conclusions and results from testing these motors, but I've tested a lot of motors, and I would say, based on these tests and the results I've seen on the track, that the Fantom has definitely edged it. And I would say it's the stator material they're using, which definitely is a different colour. It's a sort of a lovely dark greeny blue colour, as opposed to the normal steel colour that you'll see on most other motors. I say the stator material that Kawasaki, that steel they're using, is definitely giving them the edge.